Hello and welcome to the Genius Move Audio Academy podcast. My name is Paul Brewer. In this podcast, I'll chat to people who are professionally involved in the music business both here in Ireland and abroad. If you're listening to this, perhaps you have an interest in learning. Please visit geniusmove.ie, check my courses or book a one-to-one teaching session. Today's guest is Chris Walls of Level Acoustic Design. I first met Chris when he worked with acoustician Andy Monroe in about 2007. In 2014, he went solo. Since then, he's designed studios for Abbey Road, Rack, Tileyard, Coldplay, Mark Ronson, Spotify, Lucasfilm, Warner Brothers and many others, some of whom will be mentioned in the podcast. I started the interview by asking Chris about his work diary. Well, what's going on actually in terms of work? Like the last time I was talking to you, it was Google and Apple and all these sort of stuff. Have you moved away from the music, or is it just less demand in the music?
And I think that to an extent it always has been. It's music for my interest, my sanity and credibility. And then it's post-production and all that sort of stuff for the money. For the money.
I guess where the money is as well, isn't it?
Definitely more so. I mean, we're quite lucky, I suppose, the end of the music market that we be operating in, that, you know, some wealthy individuals, Noel Gallagher's and people like that, you know, he's got a few quid knocking around and can afford to build a studio, but that's kind of not the reality for quite a lot of people. So
it also is a cash intensive business, isn't it?
It's mental. It's ridiculous. I think it's the law of diminishing returns, isn't it? You know, you can get a long way with some fluff on your walls, a pair of headphones, some speakers and a bit of kit. But if you want to get to the next stage, it's a disproportionate spend to get the next 10%, 20% of quality, I think. So, you know, a lot of the studios we're doing, they're kind of netting out at about £3,500–4,000 a square metre to go from a shell and core to kind of a that's before you've equipped it or paid the electricity.
You can't really have a square metre studio.
No, actually the smaller it is, the bigger that figure gets, because, you know, your door, your aircon and all that sort of stuff is getting spread over a, you know, much smaller area. You know, that seems to be, if you want to, you know, fully isolated, really nicely serviced, acoustically treated, nicely finished space, that's kind of where it's coming out at the moment, typically. That is more commonly affordable in post-production, broadcast film, that sort of industry, than it is in music. I mean, it's still a stretch for everyone. It's just a shit ton of money, really, isn't it? So the music stuff we do, by no means is it pro bono, but it, you know, I'll definitely take more of a view on, I mean, we're only doing the design side, we're not doing the build, so the bulk of those costs aren't really down to us, but we'll take a view on the design fee a bit if it's an interesting project or, you know, feels...
Or a kudos project.
Exactly that. Yeah, the post-production guys, they pay full fare.
God bless them.
God bless them, that's it, exactly. So, yeah, but I mean, in terms of what we're doing, we're kind of like master service agreements with... So,
what's a master service agreement?
I think it just means that they can say, have a bash at this, and we can just start on it immediately without having to go through a protracted contracts.
Oh, right. So it's like a semi-completed contract.
Exactly. So we just provide a scope of works, and we I think there's like a pre-arranged rate for each staff level and all that sort of stuff. So, but within that, we're designing their facilities in the EMEA region. Currently, we're sort of looking at odds and sods in the US, but with the US side, we're kind of putting together these room standards. So in all of their territories, they're building screening lounges, mix facilities, editorial facilities and things. So we're trying to not standardise, kind of standardise the technical aspects of the design. So with these adjacencies, you need this amount of sound insulation, you know, room acoustics should adhere to this, aircon noise and all that sort of stuff. And then the power, data, fibre requirements and all those sorts of things. So we're trying to standardise that. So when they're doing kind of very high level facilities planning, they can block out the right amount of space and ensure they've got the right power requirements and things. So doing that for them. And then we've got some other sort of international post-production clients where we're doing design either globally or in the EMEA region. So yeah, doing a fair bit of that. And then on the music side, let's have a little look. We are doing some interesting stuff on the music side. We recently finished Rack Studios, which you may have seen, the refurb of Abbey Road Studio 3. God, it's looking depressingly post-heavy at the moment. Nile Rodgers.
Oh,
So
yeah, that's right, yeah.
Niall, yeah, I can't believe I almost forgot him. Yeah, it's great. So he's got a little pad in Turks and Caicos Islands, which it's quite nice. And he's building a studio there. So it's a pre-existing kind of cabin, and it's fitting that out. He wants sort of an Atmos studio, so he wants to be writing in Atmos and conceiving the music with that, with Atmos in mind. And yeah, so somewhere that people can go out to decamp for a week or a month or whatever, and record and be immersed in what the island has to offer, and that's pretty awesome. We've been looking at it for over a year, and it's kind of it moves, it slows, it stops, it moves, and I think that's to do with he's getting some partners, I think, into it, sort of technological partners and things. So he's getting all of that in play, and then it'll steam on.
Will this be a studio that you can complete an Atmos project there? Or is it just somewhere that he doesn't have to leg it into a city to work?
It's not so that he doesn't have to go to a city. I think it's that he would like to go there to work. It's a very, very, it's like a scaled down Air Montserrat sort of thing. It's somewhere that you want to be, and you want to. Yeah, I mean, I guess you could. It's you can certainly track stuff in there. It's not going to have a big live room. It will have a fairly generous sized booth. You could record some drums in there and things like that, but it's not got a live room per se. But it's a very, very large control room. The way that he works is very collaborative. I think so. You'd get half a dozen guys in there writing, knocking ideas around. But yeah, for sure, you'd be able to mix in there and sort of finalise a product.
The thing about the acoustics thing is Nile Rodgers, etc. He's rocking away. Noel Gallagher rocking away. They have the money to do it. I know sort of the answer to this because it's the same science applied to every project. How do you get around that in terms of reducing costs, and making it more, even for UK guys? How do you work that?
It's tricky. You've got if we're thinking about room acoustics and your sort of speaker response, I mean, that's kind of the main thing when we've looked at stuff in the past, Paul, it's been, how do I get a decent sounding mix room or control room? That's quite tricky. If you need to achieve a decent level of sound insulation, then you tend to compound your room acoustic issues, because by containing the sound, you're
creating more sound.
You've got pretty good rigid boundaries, and whatever low frequency absorption you might get through a slightly lighter weight partition is gone. So yeah, you compound those modal issues, and then you have to work that bit harder to get the room sounding neutral again, to sort of try and mitigate the worst of the modal behaviour. If you're going to sound insulate the room very well, and you're going to service it well, and also want to get a good sounding room, I'm not really sure there are any shortcuts.
Right.
Or ways of dramatically reducing the cost. It's not the cost of acoustic treatment or anything like that. It's all the stages you have to go through. You're essentially building a room, a self-supporting building to ensure that it's well isolated. And then you're having to mitigate, the issues that introduces, the room acoustic issues that introduces. And it all just costs money. I was thinking this morning, actually, you remember we went to Hardfi's place? Yes,
indeed.
In Staines.
Yeah.
So we were kind of pitched up with the test kit, expecting to throw the mic up and have a good laugh at how terrible it was or whatever. And it was really good. It measured really, really flat. And you find this every now and then. They didn't really have any isolation issues that they needed to deal with. So they had quite lightweight partitions. They had quite a big space. So they had a decent amount of volume, which is helping with your modal distribution at low frequencies. I distinctly remember there was a grid ceiling, a tobacco-stained grid ceiling. So it was a cab office, wasn't it?
Oh, right, yeah.
So you had So you had someone smoking away in there 24 hours a day. So you had this like yellow tarry grid ceiling. But those factors led to a good and pretty even sounding room, because the very low end, 20 hertz to 50, 60 hertz. Most of that was just going out of the walls. They were acting as sort of some sort of semi-membrane absorber or whatever. And there's acres of it, obviously, because it's quite a big room. So the very low end was pretty well controlled. And then by virtue of the size and the volume of it, the modal distribution was pretty good. You got quite a decent modal density when you get to the mid bass and upper bass. Then an absorptive ceiling. There was some other absorptive stuff they put around the room. It just kind of worked. So no work came out of that.
Yeah, indeed, yeah. Isn't that an example of science? It's the same principles applied to everything. So is that a way a guy should be thinking about a cheaper studio? Not needing loads of sound insulation.
That certainly helps. Yeah, I mean, if you're able to pick your location or pick your site, and you can be somewhere where you don't have to worry about sound insulation, or you're happy to operate at a level where, whereby you're not causing problem in terms of disturbing neighbours and things. And if the building has relatively lightweight walls, if it's a solid concrete block thing, then you're in the same boat. But a lot of places have stud partitions, fairly lightweight stud partitions. Yeah, that can be a fairly decent starting point. Certainly not having to isolate, you're going to save probably half of the amount of money, the kind of project that we're normally doing, just by not having to build floating floors, high mass walls, hanging ceilings, floating ceilings, and all of that sort of caper.
That was kind of my next question. What's the percentage between insulation and treatment then?
Something like a third on isolation, sound insulation, a third on room treatments and finishes, and a third on mechanical, electrical, and all that sort of stuff. Like broadly, it's somewhere around there. So yeah, not having to isolate the space, you're saving a good chunk of your budget there. I'd say that the aircon and electrics is always a surprising amount if you want to do that to a level where your aircon is building regs compliant and can remain on all the time while you're recording without being problematic.
Right. How did rack work out in terms of aircon and stuff like that? Because you were saying that there was some strange building elements going on upstairs and stuff.
Yeah, that was really weird. Yeah, so on the services side, it was there was a bit of lateral thinking involved. I think not by us, but by the aircon designers in design engineering. Yeah, I think where outdoor units and indoor units could be sited, where fresh air could come from and be exhausted to, and all that sort of stuff. But yeah, it's fairly standard. Aside from those site-specific difficulties, it's it's a ducted unit with some attenuation, providing very low velocity air into the room. Yeah, some of the challenges with that building had been hacked about a little bit. There was like a fireplace that had been removed but not supported structurally for 40 years probably. It's kind of been sort of Damocles kind of situation there. So that all had to be put right. And then there's I think a separating floor had been shifted at some point, and there was half a staircase sticking down through the ceiling that kind of just been hacked off with what looked like it'd been chewed off, to be honest. But yeah, so there's odds and sods like that to deal with. You kind of find that working in old buildings in particular, as soon as you start stripping out, you discover all sorts of weird and wonderful things that you then need to respond to. And
do you get that in old studios or just old buildings in general?
Old buildings in general. Old studios is quite funny. So I did Angel Studios. We did a refurb of that for Abbey Road Institute. And that's really interesting because that, when it became Angel Studios in the late 70s, I think it was Tom Hidley designed it.
Oh, right, okay. Old 20 hertz Tom Hidley.
20 hertz or 10 hertz Hidley in his later days, I think.
All right, okay.
But so there's a bit of that in there. And then Roger Darcy, Recording Architecture, did a refurb on a control room in there at some point. John Flynn did the Studio One control room around about 2000, I think. The what was the original church where the organ is, Studio One. It was one of the engineers designed that. I can't remember his name now, but sort of not an acoustician as such, but a recording engineer. Like quite a lot of those studios were designed by kind of recording engineers with a bit of nous. Yeah, so you kind of had these various different eras of studio design and different approaches to studio design. And as we kind of went through it, you're kind of unpicking that and seeing how certain people were doing certain things at certain times. It was really interesting and pretty shocking in in places. But yeah.
Should we actually talk about the science, room modes and all that?
Why not? Because I mean, I suppose the solution to that, or the way that you deal with room modes, tends to be the same regardless of the size of the room. Room modes in any room, obviously, the frequencies that are out are related to the dimensions of the room and the volume of the room. The bigger the room, the lower the frequency, the kind of the dominant modes, and where the room modes are spaced out. So where you'll hear them as distinct peaks and then gaps in between modes. In a big room, that's much lower down and after a certain point, kind of out of harm's way. But in a smaller room, like most people are working in, say it's 10 feet by 12 feet or something like that, those modal frequencies will be fairly well spaced out right through the usable bass region. So you will end up with notes that are going to sing and notes that are, not really going to hit. And if you don't deal with them, your monitoring response or the frequency response of the room is going to peak up quite considerably at certain frequencies and not others.
What sort of level can you expect, dips and etc. in the frequency?
6 to 10 dB for fairly strong ones. You can be up by 6 to 10 dB. If depending on speaker and microphone position, you can also get cancellations of an equal nature. So you could easily have a 20 dB swing between something prominent and something that's missing. The aim of your acoustic treatment, or what you're trying to achieve with your acoustic treatment, you're never going to get rid of modal behavior. You're trying to reduce the swing between the peaks and the troughs. And with positioning of speakers and mix positions and things like that, you're trying to get everything to a position where you have the best balance of energy in the room, which is why you generally see a mix position somewhere around a third or 2/3 down the way of a room's axis. The balance over all modes, the energy that you get over all modes is unlikely to be a significant peak or a significant trough around about a third of the way. If you bang center in a room or a quarter of the way along the room, then at certain modes you have a massive peak or a massive trough. So you're kind of working with the geometry of the space to try and make things less bad rather than to make things perfect, if you know what I mean. Then the treatment itself, and there are kind of three different types of treatment that you commonly see. Most commonly you see porous absorption, so foams, rock wool, all of that sort of stuff, which responds to particle velocity. So, the particles are oscillating quite wildly, and you put this porous absorption in there, it creates a lot of resistance and dissipates that sound energy as heat. Particle velocity is maximum for any given frequency, a quarter wavelength away from a boundary. At a boundary, it stops and reverses. So particle velocity is 0 at a room boundary, and it gets progressively greater as you move away. Then you've got kind of membrane absorbers or panel absorbers, that kind of thing, which it's generally a mass on a sealed cavity, so a mass spring system. And that responds to sound pressure being a maximum at a room boundary, which is why if your sofa's right up against the back wall, you get a massive bass tilt up because sound pressure is much greater there. So what you most commonly see is porous absorption in a studio, and that's what you typically buy off the shelf as acoustic treatment. It tends to be porous absorption, and your bass absorption is a triangular wedge of foam that sits in the corner of a room. How effective that is obviously questionable because it's working with particle velocity, which is going to be 0 at a room boundary, so it needs to be pretty sizable.
So that means the worst place you could put a bass trap is up against the wall.
A porous one. Yeah, which is why, going back to Tom Hidley at Angel, his approach to low frequency absorption was the hanging panels of mineral wool or plywood with mineral wool, or it's sometimes bitumen with mineral wool on it. They might be 3 feet, 4 feet deep, and they'd be on the side walls, on the rear wall, on the ceiling. So, at that sort of depth, you are genuinely hitting some of those low frequencies, but wouldn't be markedly different in its performance if it was just meter depth of rock wool or a couple of 100 millimeters of rock wool a meter off the wall or whatever. It's really hitting that kind of quarter wavelength sort of point. Whereas the pressure-based absorbers, like a membrane absorber, is going to be most efficient at a room boundary, and by manipulating the mass of the membrane and the spacing, you can absorb pretty low frequencies with fairly little depth. So, you might get 50 hertz, something tuned to 50 hertz in 100 millimeters or so. So it's a massive space saving, but obviously they're not as efficient as a porous absorber at a quarter wavelength. That'll absorb in theory 100%, whereas a membrane absorber might be absorbing, say, 60%, 70% at its resonance.
So you'd need more of them?
Yeah. Typically, you need more area to achieve an equivalent absorption area. But then if you're in this situation with the lightweight walls and stuff, they'll be doing quite a lot of the work for you as well by letting the sound just go out. In this sort of situation of a kind of a more modest control room or mix room or studio or whatever, but any room like that, what you're trying to do is get a balance of low frequency, mid frequency and high frequency information. You don't want a room that's stuffed full of foam and no low frequency absorption, and it ends up dead as a doornail, mid and high frequencies, but it's kicking off at the low end. You kind of want a fairly balanced energy spectrum. So what we were talking about before, I suppose, I was thinking about it in terms of specific modal control. So trying to reduce the peaks and troughs at those frequencies, which you are naturally going to peak and trough in your room. If you can do a bit of that, then the rest of it is kind of balancing the energy in mid and high frequencies, avoiding flutter echoes, and trying not to overkill the room, but give yourself a sort of nice balance of energy. Looking at first reflection points and all the basic stuff that Sound on Sound will have been banging on about for 30 odd years. That's kind of the aim. So if you're lucky with your room dimensions and you've got a decent amount of volume, no neighbours that are going to get annoyed, then that doesn't necessarily need to be a very expensive endeavour. But if you've got a perfectly cubic room in a flat block of flats or something like that, then you're up against it, I'd say.
Right.
There's something I was chatting to a client about last week was that you get used to a room. If you're working in the same room all the time, you will get used to that. You will learn to tune out certain defects or characteristics of the room. You'll get to know how it sounds and what a good sounding product should sound like in your room. So you kind of calibrate to your space to a fairly large degree. There's some sort of cognitive process going on in the background, which ideally you wouldn't have to do, but you will fundamentally get to learn your room and be able to work with it. I think maybe the difference with what we're generally dealing with at work is, a commercial facility where there's a guy who might be coming in for a day, and he needs to sit down and be able to work intuitively from minute one. He needs to trust what he's hearing back and not have to do, an hour of learning and then get his brain working on unpicking the foibles of the room. He kind of needs to be as right as it's possible to be right from the off. So that's another factor to bear in mind with, if it's a studio for you and you're going to be working in it all the time, you're the engineer, then you get a certain way down the line with treatment, whatever your budget allows, and you learn the room and learn to work with it.
Learning the room, I just find a little bit difficult in terms of absent frequencies. But does your brain fill them in, or how do you reckon that works? Like if you're not hearing something.
Yeah, that's a fair point. Well, yeah, it's not a perfect solution.
Okay.
But yeah, I guess that's maybe where headphones come in and stuff. Yeah, it's a tricky one.
Right.
I don't really know the answer to that. I know so. I told you this before, I think, but Fraser T. Smith had his studio at Matrix a little while back, and he does this ear training thing at the start of every day. So it's one of these apps where it will play, say, pink noise, and then it will boost or cut a particular frequency band, and you can tell it octave band, third octave band. It can do plus minus 3 dB, 6, 9, whatever it is. Test himself, see how he's working. It's good to get a feel for the frequency range and what a 3 dB boost or cut sounds like. And he was getting 95% all the time. He was really, really hot on it. But where he was falling down, it was always in the 60 hertz region. So we started looking at his monitoring, and he had some Genelecs with the GLM set up. And I measured it, and it was the most suspicious plot I've ever seen. It was like someone had drawn it with a ruler. It was unbelievable. But you look at the phase response, just all to shit at 60 hertz, because it was just a boundary interference thing. So rearward radiation from the speaker, hitting the wall behind, coming back 180 degrees out of phase. And I think what the GLM done had cut everything either side of this 60-ish hertz. So we just switched the GLM off, and it still had this massive notch, and the phase response around there wasn't very good, but the phase response was much improved. And he started to be able to hear stuff a little bit, what was going on there. He was doing a little bit better. Then we started moving closer to the wall, shifts the notch frequency up and playing around with that, all of which was helping. But what we did in the end, he got some Geithane. It's a German speaker.
Oh, yes, indeed. Yeah.
So they're like dual concentric fellas with a cardioid polar pattern at low frequencies. But they genuinely do, in that notch almost completely filled in, because there's significantly less rearward radiation. There's less cancellation and less phase weirdness going on. His scores on the ear training thing went up massively from that. But yeah, he kind of figured out that if he was reaching for that 60 hertz EQ, he needed to reference on a different speaker or go onto headphones or whatever. Really understanding how important phase response is to what you're hearing. You kind of look at frequency response graphs all the time, but that's only half of the story. But the temporal side of that is is so key. You know, a flat frequency response with a crap phase response is no use to anyone. And, you know, a better phase response with a compromised frequency response is more useful, I would say. So some lumps and bumps in the frequency domain for a relatively clean phase response, that's a very good compromise to make.
In terms of the smaller lad, how big is big enough?
For a room?
Yeah, or control room, like specifically, like say. Like it multiplies the problems hugely by having a smaller room.
Yeah, it's kind of, I mean, the smaller a room gets, the more complicated the acoustic solution gets. You know, the smaller a room, the harder it is to make it sound good. So I don't know. I mean, up at Tileyard, some of those rooms up there, actually, I'll tell you what, we just did a load of rooms in Wakefield for Tileyard. So they weren't that big. They might be in like 11, 12 square meters. So
all right,
that?
Okay.
Yeah, not big rooms at all, and
3x4.
Yeah, that sort of ballpark. I mean, maybe even a bit smaller than that, but somewhere around there. We had, what were the ceilings? They'd been about 2.7 meters, something like that. So what's that? 9 foot. Not huge spaces by any stretch, but fairly carefully designed, and yeah, they're good sounding rooms, very good sounding rooms. We would have gone up there. I think they had Neumann KH310s in them, something like that. So they've got a little bit of tweakability on the back of them. So we went into each room and, you know, rolled off the bass if it was needed, or there's fettled them to get them as good as they can, and also by measurement and by listening, fine-tuned the positioning of the speakers, because, you know, that makes a huge amount of difference. You know, move a speaker 5 centimeters and it's all of a sudden exciting a completely different set of room modes sometimes. So experimenting with speaker positioning and the desk positioning to kind of push that listening spot, you know, where things are going to sound better.
Which was what in a 3x4 room?
Pretty much as tight to the front wall as we could get it. But, you know, obviously you've got 3 foot of desk and all that sort of stuff. So you're probably going to be about a third of the way along the length of the room. I think that's where most of them would, well, all of them probably would have ended up. But yeah, I think you can get some pretty decent results out of a room of that size. We did post-production room, sort of QC room, which was, what's the name of the company? I won't say it out loud because I'll get in trouble. But we did this Atmos room that can't have been more than about 8 square meters. It's absolutely tiny. I'll show you a drawing of it.
Now, when you say like 8 square meters or 12 square meters in the 3x4 room, is that the measurement plus the treatment or less the treatment?
I'll find both floor plans and tell you, because I'll get it wrong otherwise. So that probably is about 9 square meters. I mean, there's a bit of, it's not wasted space, but, you know, space used for treatment and what have you that isn't usable floor space. But that can't be more than 11 square meters before you start treating it. And that's got a 714 Atmos setup in it, like properly crammed in. Sounds all right.
And yeah, that's what I was going to ask you. Like, Atmos is a sort of a broad spec, really. You can fit a lot of stuff into it. It doesn't have to be as tight as some of the other ones, does it?
The Atmos Music came out of an Atmos HE specification from Dolby, which used to be certified. So it was quite prescriptive, and you needed to have the layout length, width, height, all at least hitting certain figures, and the sound pressure levels at the mix position had to be at least a certain level and all of that. They've stopped certifying those rooms. So those criteria are now guidelines. We would always adhere to those guidelines because they were there for a reason, but no one's coming to certify your room. So, you know, in theory, there's a bit more flexibility with how you choose to implement it. You know, the angular separation between all the speakers is important. And when you go outside of those recommendations, things do start to sound a bit funky, I think. And particularly with the height channels, if you've got very low ceilings, the height channels they don't sound quite right. You need to have them very close together to get the angular separation, and yeah, it all starts to fall apart, really. So Atmos rooms do benefit from having a bit of size and a bit of height. Have you had much experience? Have you been in any Atmos rooms?
I haven't yet at all.
Would you have time to come and see some stuff?
On holidays, yes.
Oh, good stuff. I'll get you in some places because it's like, it is amazing, Atmos. You know, good stuff that's been well mixed in, you know, with Atmos in mind, or maybe even written with Atmos in mind. Listened to in a good studio with, you know, good acoustics, good speakers that's been lined up. It's amazing. And when you switch back to stereo, it sort of sounds a little bit disappointing somehow. But my only experience of Atmos is listening to it in that sort of environment. I haven't heard the kind of the consumer format, you know. Yeah, and I don't really know what that is. I've just missed out on the Dolby car a few times, but I can imagine in the car it would work quite well because, you know, you have scope to put stuff around you. You've got a known and defined listening position and things. But the domestic playback solutions, I haven't got any experience of. But I mean, I've got these like the binaural headphones and stuff. But to be honest, that did nothing for me. Good content in a good Atmos setup is a great way to listen to music.
Now, as I say, I'm looking forward to visiting one because I haven't. And a mate of mine, Aidan, has been in some in the US, and he says it's just phenomenal. The whole process is phenomenal. But what's sort of phenomenal about it? Is it the fact that it's new? You know, have you not experienced sound in that way before? Is that one of the elements?
Yeah, there's definitely a bit of that. But it's I think it being phenomenal is quite dependent on the content. There's some stuff that, you know, I remember it wasn't Atmos specifically, but I remember there was an Apple promo thing when they had their binaural Apple Immersive or whatever it was called, where they took What's Going On by Marvin Gaye. If ever a song didn't need to be put in Atmos or touched, generally, I would say, it's probably that. So I didn't understand the point or the motivation for doing that. Whereas Billie Eilish, that's something that quite often gets played as an example. And with, you know, having the 300 or 180 degrees or 2 pi steradians, that's probably a more accurate way of describing it, to play with for that sound field. It moves everything out of the way of a vocal that is just so in your face and so clear. And yeah, I don't know, it made so much sense for her music.
Is it stereo but more? You know, do you have is that the experience you have, that it's more stuff?
No, so in that specific example, the Billie Eilish thing, it's the same amount of stuff, which is quite a lot generally, but it's just pushed out. It gives everything much more room to breathe. Right. Which for me, just let the vocal do something different. It felt really sort of close and personal in a way that it didn't for me in stereo. Okay. There's some of the other demo stuff that gets rolled out a lot. There's an Imagine Dragons track, Believer. I think that was quite an early Atmos mix, and that sounded like a guy getting excited about having a joystick to, you know, whiz a keyboard from front to back all the time. And, you know, so there's a lot of movement in that, which is quite interesting. Is it musical? Is it to the benefit of the track? Probably not, but it demonstrates, you know, how you can move sound around. But yeah, maybe that's a little bit gimmicky. But I think, you know, a lot of the mixes I've quite enjoyed, it's been a fairly static sound field, but it's just spread out around you a bit more. I don't know. It's hard to explain. You'll hear it.
Yes,
you'll hear it, and you'll know what I mean.
I'm looking forward to that.
Yeah, for those ones where it's, in my opinion, being used sort of really, really artistically, when you go from the Atmos mix to the stereo mix, it's like going from the main monitors to the NS10s.
Right.
It just all of a sudden, you know, it's all the same stuff, but it will just starts to feel a little bit disappointing.
And in terms of designing a room for that, is it difficult insofar as you don't have, you know, the live end, dead end, whatever concept, or, you know, treatment at the front and no treatment at the back kind of thing? Does it all have to be right all the way around? Is that how it's approached, or are there different things? Rightly
or wrongly, you know, and this is the start of every sentence in acoustics. Yeah. So, I mean, for me or for us, the left, centre, right are kind of the most important channels still in Atmos. that's where most of the content comes, and that's where your ear is more attuned. You're more attuned to sound coming from there. Your perception of sound from behind you and from above isn't as good. So, every speaker is important, obviously, but some are more important than others, I think. So we'd still kind of design predominantly based around the left, centre, right. And then probably the side surrounds would be the next most important. But the ones that are behind you and the ones that are above, your ear isn't going to judge them as critically as it is those other speakers. So we kind of...
so is
we're trying to...
In the Dolby spec, you still have the front two or the important speakers, and the ambient ones, whatever, are smaller speakers. Is that how it works?
Every speaker has to have a minimum sound power level at the mix position.
Right. So
it's, that they all, in an ideal scenario, they're all exactly the same speaker.
Okay. That's
almost never the case. So they would tend to be smaller, and the surrounds can be smaller and bass managed. So you've got a sub at the front that's dealing with the low end for eight of the speakers. Say, the Dolby spec would ideally like you, I guess, to be using the same speaker all the way around, so that it's all consistent. But that it's not a financial reality or a spatial reality.
Especially when you're converting a room that's already there. Because I think you mentioned before, a lot of guys are actually doing that. They're turning their old rooms into Dolby rooms.
There's a bit of a rush for that. As record labels are kind of converting back catalogue or offering an Atmos mix of back catalogue, there's a bit of a bum fight to get hold of that, I think. That's slowed down a bit now, I think. But a lot of the new studios that we're doing, it's just a default thing. You'll make it Atmos compliant, because why wouldn't you if you're going from scratch? Yeah, but the spatial things is huge. And then the cost of the speakers, if you're going from what was a stereo pair to 12, is it? Minimum, probably 14, 15 speakers or something like that. It's a massive increase in cost of that. And then, the converters that you need, the processing for those speakers as well that you need. It's an expensive endeavour.
What do you think of Sonarworks and all that sort of room EQ gubbins?
Pretty good. Ricky Damien.
Yes.
Did you ever meet Ricky?
Ricky.
I did a sort of studio for him at his place, kind of in a spare bedroom, and we did some fairly basic treatment in there. And then he had Sonarworks kind of mopping up the rest of it, and it was really good. It was really good, actually. I think particularly, as I understand it, some pretty recent or more recent versions of it, you've got a bit more control over the frequency range that it operates over, whether it only cuts or whether you're going to allow it to boost as well, and all that sort of stuff. But the key with that seems to be there's a mix, isn't there, like dry wet mix, or something, and it definitely seemed to be most effective when it was around sort of 70%, something like that. So not absolutely slamming the Sonarworks, but letting a bit of the natural response through as well.
Okay,
if you know what I mean. But it's quite good. I think like with all of these things, if you're going into a bare room of 15 feet by 10 feet or something that's got a 1 second reverb time and expecting Sonarworks to sort you out, you're going to be disappointed. But if you've put a bit of time and effort into treating the room to some extent, and then you're asking Sonarworks to kind of mop up some of the lower frequency peaks and troughs, then it can be a really powerful tool. Obviously, the aim for us is to ensure that none of our clients ever have Sonarworks or Trinov or anything like that in their room. But sometimes budgets or circumstances mean that it is a useful tool to just tidy up the last little bits.
But the other thing I was going to ask you was about the Trinov as well. Like, what's the difference in terms of quality and?
So my colleague Matt would be able to give you chapter and verse on all of this. It's it gets a bit above my head quite quickly, but I think, I'm not entirely sure, but Trinov works with, it kind of measures what's going on in the frequency and time domain, and it creates a filter to invert that.
Okay.
I believe that's what's going on there. Whereas I think, and again, I could be wrong, I haven't looked at any of this stuff, that Sonarworks is a slightly more straightforward EQ based thing. So Trinov in theory is correcting things in the time and frequency domain, whereas Sonarworks is working in the frequency domain only.
Right, okay.
I'll fact check that and email you.
Yes, indeed.
The question that I ask and lots of people ask, I'm sure, and I've either not listened to the answer or haven't been given one, is you can only really correct for the time domain at one finite point in space. But as an engineer, you're doing this, or, tiny little movements around all the time, or you're going over to your hardware and things like that. So how well does that time domain correction work in reality when you're moving?
Yeah, but like
around all the time.
The way we used to do it was just take an average, sort of, Is that a solution? I don't know.
Well, so with frequency, I kind of get that. With time, yeah, I don't know. I mean, with an average, you're not right anywhere.
Absolutely, yeah.
Presumably,
but you're nearer right in a lot of places. Is that an argument?
I can't think how that works in the time domain. Actually, Matt's much cleverer than me. He'll be able to tell you. Yeah. So I don't know. We had this thing we did for Phoenix Studio in Gothenburg, where he had a room. I can't remember who designed it, and he had some ATC SCM 300s in there, 5.1 system, and he had some issues with his room response, and he had a Trinov in there that was kind of making things work all right. And he decided he wanted to upgrade the monitoring, or change the monitoring rather, to PMC QB1 XBDs, the big fellas. We kind of helped him to do that integration. But while that was going on, we made some changes to the control room treatment to try and fix some of the issues that were in there, which we did, I think. And he kind of got the speakers up and running, got it all set up with his Trinov. And after about a month of having the Trinov on and off, he got rid of the Trinov. Because I think it was making, by that point, such a small correction, but you could hear the correction it was making. And I think he preferred, it was probably the phasing again, I think he preferred the slightly lumpier, unmolested response to the speakers to the one that had been processed.
That's interesting.
There's a paper, I think it's Francis Rumsey, I think it was. He was one of the lecturers on the Tom Meister way back when. He wrote about this, the subjective preference for amongst educated listeners for a slightly lumpier frequency response without correction over one that had correction but was flatter.
Right.
The correction presumably being in the frequency domain and not the time domain.
So that's how Chris Walls does it. Many thanks to him for his time and effort in making this podcast. Do visit geniusmove.ie to find out about recording courses to suit you. Thanks for listening.